Learn how to solve a projectile motion question using kinematic equations. So to start, let me show you some of the kinematic equations that we use along the x-axis and the y-axis in projectile motion. I'm going to turn this up a little bit. Axis along the y-axis. So to start, the equations which we use are simply a slightly altered version of the normal equations which we use in kinematics, except that we need to take into account that this is Vx and this is Vy. So we have a sort of two-dimensional thing going on here, which is different from normal kinematics. So Vx is constant. As you can see in this diagram, Vx is over here and it is consistently going straight ahead, which is called uniform motion. Next, we have along the y-axis, which is a acceleration which is constant. As you can see over here, Vy is along this vertical line and it is consistently going straightly downwards and is probably becoming faster along this area. Okay, let's move to what the equations are. Oh, and this is called uniform accelerated motion because it is consistently increasing in speed. Now, let's talk about what the formulas actually are. X equals, or xf for the final position, equals Vx multiplied by t plus x initial. And unless this is specified in the word problem, we always consider this to be 0. Now for this side, we're going to talk about the y-axis equations, and we have y maximum, which is the maximum height, is 1/2 ay t squared plus viy t plus y initial, which is also usually 0. Now, on the other side, on the next equation, we have Vy equals 1 ayt plus Viy. And the last one is Vy squared equals Viy squared plus 2a multiplied by delta y. So as you can see here, it is really similar to our normal kinematic equations. We've just adjusted them to have along the x-axis and y-axis accordingly. Let's solve one of the questions. Here we have one that's telling us to find the ball's vertical velocity using just one variable, the time. Now, this seems really complicated, but in reality, it's quite easy. Let's have a look. So first of all, we're going to use one of the equations, specifically this one, but we're going to take out Viy because we don't need it. It's not even provided in the question, so we're assuming that it is not going to be a part of the equation. Vy equals ayt. That's all we're going to use. And in this case, when we write the gravity acceleration y, it's going to be positive 9.8. Acceleration in projectile motion is always gravity. So 9.8 multiplied by t, which is 1.2. So let's take a step back. Why is this positive? Well, we know that gravity is always going downwards, and this ball is also going in the direction of gravity, which is downwards. Therefore, it's going to be positive. Now, on the other hand, if the ball was being thrown upwards or was launched like a projectile, we would say that it's going to be negative because it's opposing the natural direction. To take this number, plug it in and the calculator, and find out that the answer is 9.8 multiplied by 1.2, 11.76. So I'm gonna put this over here, 11.76 meters per second, because this is Vy. With this information, we know that it is about 12 meters per second, the closest answer being B.